All right, folks, we are starting into the wonderful world of synthesis in chapter 11. You've gotten a little bit of a taste of it with moving around functional groups like you saw in chapter 8. Chapter 9 started to show you how you could use multiple reactions to build carbon chains. And that's one of the big goals of organic chemistry, is that you learn all of these individual reactions so that you can solve bigger, more interesting problems and you can build larger molecules. Chapter 11 is designed really as a way to give you some strategies for thinking about synthesis problems. There aren't any new reactions in this chapter, but you will use this chapter for the rest of your time in organic, especially if you take Organic 2 with me. Synthesis, I think, is a really important part here. It requires you to use your brain in a little bit different of a way than you do in other to solve other kinds of problems. It is challenging, it is fun, it is rewarding, and it requires that you have patience with yourself and that you take some time to really practice. Do not put this week's lab off. This week's lab is a quote-unquote synthesis dry lab that is just practice problems and doing multi-step synthesis. In your lab this week, it will be a worksheet, and your whole 25 points will come from that worksheet. There will also be a video where I help you start and work through a couple problems with you. This is not something that is easily done on the fly, right? If you wait till the last minute, you're going to have questions. I am happy to look over your solutions and to help you with them, but you have to get started early for that to work. As we go through chapter 11 here, I'm sure I'll have more little tidbits of wisdom to throw your way. All right, so 11.1 really just reviews what you saw previously, is what you've started doing in chapter 7, 8, and 9. It's the one-step synthesis. This is, when I say synthesis, I'm not typically referring to one-step synthesis. These are your product predictions, your reagent predictions. This is solving I start from A, what do I use to get to B? They're the most straightforward type of synthesis problem. All right, here, instead of giving you the product, you're asked for the reagent. That is a problem type that I do enjoy. Synthesis builds on that. We give you some sort of parameters on what you can start with and a goal of what you can finish with or where you need to end. It's not always just as easy as, okay, I need to add BR2 and I'm done. All right. Oftentimes we have to come up with a series of reactions, a synthetic route. Functional group transformations are functional group transformations were introduced in chapter 8. All right, we know that we can move functional groups with a combination of elimination and addition. We can move double bonds. I think that's on the next, no. We can move double bonds by using addition and then elimination. You have to understand the reactions that we've already asked you to learn. You need to understand regioselectivity, Markovnikov, anti-Markovnikov, Zaitsev, Hoffman. These are important in manipulating your structures. You need to understand limitations and possibilities, right? Klein gives you a lot of really useful summary slides that can be really helpful when you're getting started on synthesis. If you look and kind of think of them as flow charts, right? You have all of these different reactions that you've learned, and if you want to get from one point to another, right, it's a roadmap. If you're moving around an alcohol, is the same thing as moving around a bromine. You need to eliminate and then add. However, with an alcohol, there's a little bit of an extra added bonus to consider, it's not a good leaving group. So you have to make it a good leaving group. You can use tosyl chloride, and that's recommended because then you can be really selective with what base you use, right? Sodium ethoxide is a smaller strong base, so you get a Zaitsev product. Tert butoxide is a bulky base, so you get a Hoffman product. You could also use H2SO4 to do acid catalyzed dehydration, but that is specifically going to give you that Zaitsev product, right? So you do have options. You're going to have multiple options. That's something that's really important that you need to keep in your awareness. Synthesis problems often have multiple solutions. And the reason that I bring this up is because if I give you a practice set and I give you solutions, it is super important that you recognize that that is a possible set of solutions. If you don't come up with the same thing I do, I don't want you to immediately go, I was wrong, okay. I want you to think more critically. Am I wrong? Did I make a mistake? Or is this an alternate path I could use? And if you don't know for sure if what you did was right, but you think it might be a different solution, send it to me. Let me look at it. Let me help you. I will be able to tell if that is, a valid way to go, or if you made a mistake somewhere. I can help you with that. You have to do this, of course, before things are due and before tests are underway. So it does require you to work ahead here. All right. Looking at this sort of roadmap here with alcohols, right? You then have multiple ways of adding alcohols on Markovnikov or anti-Markovnikov. You can always go backwards as well. And I mentioned this a second ago. We can move alkenes around with addition and elimination reactions. We still have to pay attention to regiochemistry, right? If I want to move this double bond out of the ring, well, then I need the bromine to add to the more substituted side, and I need a Hoffman elimination. If I want to move it further into the ring, then I need a anti-Markovnikov addition followed by in this case, a Hoffman elimination. So there's a lot of choices here, and if you don't know the reactions that we've gone over in the last 4 chapters, really, this can be really tricky. One reaction that I have I have taught you guys, and you've learned through chapter 10, is really a gift. You only know one reaction for an alkane, and that is radical halogenation, so using Br2 and light. So if I ever make you start with an alkane and you have no idea how to get to the end, you should at least be able to get partial credit because you know the first step. There are no other reactions that you have learned up to this point that work with an alkane. From there, you can do substitutions, you can do eliminations. Once you get a double bond, the whole world of additions is opened up. You can transform it into a triple bond from there. You have a lot of flexibility, but it is super important that you know this reaction so that you can get from an alkane into any other functional group. When it comes to reductions, you also have a lot of possibilities, right? You can go from a triple bond to a double bond, and you have 2 options there, and it depends on what kind of stereochemistry you want, cis or trans. You can go down to an alkane. You could go straight from the triple bond to the alkane, also using H2 and platinum. You can go in the other direction, right? Alkane, like I said, Br2 and light is your only option, really. And then you can eliminate to get a double bond. If you're trying to get to a triple bond, right? You can put a bromine. Oh, goodness, what am I doing? In step 1, you can put a bromine on either side. And then in step 2, you can eliminate with excess Na and H2. Now, working up with water just prevents you from having that negative charge there. That's the only reason you need that. When it comes to strategy, and it's very important that you have strategy to avoid freezing up in assessment situations. When it comes to synthesis, there are a couple of key questions to start off with. And really the first one is, how much carbon am I looking at? Am I extending the carbon chain? Am I adding more carbons? Am I losing carbons? Am I making a shorter carbon chain? And one of the nice things about that is you don't have many options at the moment for extending a carbon chain. So if you are extending a carbon chain up until this point, there are 2 options, right? You could have a terminal alkyne where you remove, number 1, you remove that terminal proton with sodium amide, NaNH2, and then you put in some sort of alkyl halide. And that is going to give you still have your triple bond, but that will put another R group on. The only other carbon-carbon bond formation that you have learned is super, super specific. It's useful, but it's very, very specific. If you have an alkyl halide and you react with sodium cyanide, right? This is an SN2 reaction. You will get a new carbon-carbon bond here, but it's important to recognize that carbon will have a triple bond to nitrogen. So it is possible, but up until this point, you don't really, unless you're trying to make a nitrile, this little guy up here is going to be a little bit more useful. Now, if you're trying to make a nitrile, obviously make a nitrile, but if you're not, and you're just trying to extend the carbon chain, this is the one you're going to want to work with most frequently. Now, in chapters coming up, we will see new reactions to extend carbon chains, and those things just make it all the more challenging. But what I want from you right now is to practice with the reactions that you have. That's really important to me in these synthesis problems, especially when we get to the lab. You can Google these problems and get answers. I know this. I want you to use reactions that we have learned only. If you bring up some wild reaction that you found on the internet, that is not going to cut it right now. This is designed to help you work with the reactions that are in Organic 1 and this class specifically. So, be thoughtful about that. So changing the carbon skeleton, as we've mentioned, we can increase carbon. We can also decrease carbon, right? So this first section was taking the number of carbons up. If we want to take the number of carbons down, right now the only thing we know is ozonolysis. So if I give you an example problem that has, 5 carbons and then the product has 4 carbons, right? Ozonolysis is going to be your friend. Okay, so we're just reviewing here. Is there a change in the number of carbons? So, how to approach a synthesis problem here? Is there a change in the carbon skeleton? Yes. Right, we are going from, thank you. We all know my battery is low now. We are going from 1, 2, 3, 4, 5 carbons to 1, 2, 3, 4, 5, 6, 7 carbons. All right, so 5 carbons to 7. So we need to devise a plan. You can work on these problems in 2 directions. We can work forwards and we can work backwards. This one, I think it's going to be easy enough to work forwards. So let's start there. We can see that we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So in the place where there's a triple bond here, we have a double bond here. So that's doable, but let's do that last, because if we make this into a double bond, we can't extend the carbon chain. All right, so I'm going to go down and around to do my synthesis work here. I know if I treat this with NaNH2 and a 2-carbon alkyl halide, I will extend my carbon chain. So 1, 2, 3, 4, 5, 6, 7. Right? So 1, 2, 3, 4, 5, 6, 7. Now all I have to do is transform the functional group, and I need a trans double bond, so I'm going to use my dissolving metal reduction. All right, and I worked through that relatively simply from the beginning. You need to be patient with yourself. You are going to start off and you're going to work yourself into a corner and you're going to have to start over. It happens. This requires practice. This is a tough skill. All right, and so let's see. Did Klein and I come up with the same solution? We did. You can also write multi-step solutions on one arrow, where it would be NaNH2, followed by CH3, CH2Br, followed by the reduction. And then that, that I'm going to draw it really small here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 4. There it is. You can draw it like that. I don't suggest turning in work this way. One, it's a little harder for me to grade, but it's easier for you to catch mistakes if you force yourself to draw the intermediates. You don't have to on a synthesis problem. I will, if you give me this right here, I will grade this. But if you make a mistake up here and then the rest of it doesn't make sense, right, the partial credit's going to dwindle. One of the nice things about presenting in this way here is that if you know that you need to get from, A to A2, but you don't know how to do it, you can put this in. You could write magic or leave it blank. And then maybe you know that you need that dissolving metal reduction in the last step, and it can help you get to partial credit. So just because you don't know what the first step should be, don't let that stop you. You can fill that in later, or it can be a way to get partial credit. And so here you go. There's another way to present it. All right. In the next video, we're going to tackle retrosynthetic